All right, so we're going to go ahead and get started. So I'm going to jump right into this walkthrough and step you through the process of this assignment. So the goal of this lab is to further your learning of t-tests. Specifically, you will be able to find the differences and similarities between one sample, independent and repeated measures t-tests, as well as conduct the latter two analyses on SPSS. So we looked at one sample t-test, and now we're going to be looking at independent samples t-tests. And basically what this is we're adding on to what we learned before, and we're just doubling it. And as the theme goes with spearmint gum, you're just doubling the fun. So let's go ahead and dive on into it. So up until now, we focus on one sample when making inferences about population. This lab will help us further understand the inferential statistics by using more than one set of data. So we saw here in our example of Massachusetts and the entire population of children in Massachusetts, and perhaps maybe these are adults in our example because we're using marijuana and other substances like that. So let's say this is the population of adults, and we're comparing this population of adults to a sample, and that would be a one sample t-test. Now what we're going to be doing is we're going to compare a population, or we're going to actually get our data from the population. Once we get our data from the population, and we're going to split them up into two groups and then compare these two groups. So these are going to be mean differences between two samples rather than a mean difference between a population mean and a sample mean. So we're just looking at two samples instead of one, and that is the basis of the independent samples t-test. So let's look at this right here. Our null and alternative hypothesis is going to be written slightly different. So we're using mu here, as you see here, and it's mu base 1 and mu base 2 equals 0. Let's say we have these two groups. We have the marijuana user group, and we have the caffeine drinker or coffee drinker group. That would be group 1, and this is going to be group 2. And so you can write it coffee group, and you can write it as, or I'm sorry, this is going to be marijuana group, and you can write this as coffee group. Or you can just write as mu base 1 minus mu base 2. And theoretically, if you subtract the means of these two groups and it comes out to be 0, then there is no difference. It's essentially saying the same thing as this. Mu base 1 minus mu base 2, they're equal. I'm sorry, mu base 1 equals mu base 2 is equal. So 5.5 minus 5.5 is equal to 0. And 5.5 equals 5.5. So you can write them both ways, and as you see here in the alternative hypothesis, you can do the same thing with it. So logically speaking, you're saying that the groups are not equal, and in that case, you are being able to just have an alternate way of explaining the null. Let's say you do have a direction and it's a one-tail test. Then what you would do is you would pretty much write out the, like in this case, if we're using math score as our outcome, these are the marijuana users and these are the coffee users, group number 2. And you would say, if you're picking direction, you say that the coffee users are going to have a better math score or average math score than the marijuana users. And this is represented by this is greater than this. Or you could just write it as group 1 is not equal to group 2. The mean of the group 1 is not equal to group 2 mean. So hopefully that makes sense. Let's go ahead and move on to what we need to do before we even perform the analysis. So now that we set up our null and alternative hypotheses, the next thing that we need to do is the very next thing that we need to do is we have to actually look at our data. And so this is our data right here. And then you just want to double check to see what you have here. And what we have here is participant ID number. And then you have the pre and post test score. This is going to come later when we do the repeated measures test. Today we're just doing an independent measures test or independent samples t-test. And we have these two groups here. So this is indicating treatment group 1. And then this is indicating treatment group 2. So the way SPSS writes it is this variable right here is split up. So if I was to toggle this, this is represented by the 0, did not watch the debate, and this is represented by a 1, did watch the debate. And what we're doing is we're comparing their intention to vote right here. Here are all their scores. And so if I was to go in the variable view, this would make sense how I constructed these variables. So I was able to put designated 0 for did not watch the debate, and then designated 1 for did watch the debate. And that's the way this variable has been constructed. And as you can see here, you can find other details about it. And they just designated as a nominal. And this of course is your DV, intention to vote, and it needs to be on the scale. All right, so we looked at the data, everything makes sense, there's nothing missing. We know what everything is. So let's go ahead and move on to performing our assumptions. So whenever you engage in any sort of statistical analysis, you have to have your assumptions met. That's ideally you want to have all your assumptions met before you move on. Not all the time will your assumptions will be met, but you want to at least give it an attempt, and then if you don't have your assumptions met, then you might have some biases in your results. So the assumptions for a one sample t-test is, or independent samples t-test is similar to a one sample t-test. So the values are independent observations. So think back about random sampling when we learned about probability. A sample is independent random sample. When selection odds aren't affected by the previous selection. Thus, values are independent when there is no relationship between them. And then the population is normal. So you have a normal population, normal distribution. So in this case, your samples follow that bell curve, and their skewness and kurtosis are within the bounds of what is appropriate. And you also have homogeneity of variance, and this assures that the variances between the two samples are equivalent. If they are not, the interpretation of the t-statistic may be inaccurate, and there's a specific test that we can perform in order to make sure these assumptions are being fulfilled. We're not going to do this today, but just keep this in mind because later on we will perform these assumptions on the SPSS. All right, so let's go ahead and move on. So now we're going to be doing some calculations for this assignment. I'm going to move on to here, and as you can see here, this kind of represents what we have. We have our unknown population mean, and then we have our sample, and our samples are making inferences about the populations. And I really should probably label this as marijuana users, because I guess they're eating brownies or something like that, but you know, I want to be a little bit better with this language. Okay, so you have a sample that is given marijuana brownies, and they're representing a population. So we're going to use this symbol right here, mu. In a similar fashion, the coffee drinkers are going to have a representation. If the assumptions are fulfilled, they will represent the population, more or less. We can make inferences. And as Geoff Cummings would say, the art of using information from a sample to estimate what might be true about the population. That's his take on an inference. So we have this information here, and we looked at our assumptions, assuming that we did. And I'm going to go ahead and move on because I think we already have a good grasp of the null and alternative hypotheses. So as I was saying before, calculations of independent samples t-tests, just think double of a one sample t-test. So in the case of your n, your sample, so you're going to have n1 for sample A and n2 for sample B, because we have our data that's split up into two samples. And in our case, if I was to look back at SPSS, I have in my data is going to be different than your data. But I have 22 participants, or actually, sorry, 21 participants for category did not watch the debate. And then I have an additional 21 participants for category did watch the debate. So I have 42 participants in total, 21 from category 1 and 21 from category 2. All right, so let's go ahead and move on. So looking at this, we have some other equations here. I'm going to go ahead and move on to this part, and it's synonymous to what we see right here. So remember that when we were looking at degrees of freedom for one sample t-test, it was just n minus 1. Because we have two samples, we're just doubling it. All right, we're just adding these up and then subtracting it from minus 2. Pretty straightforward. It's going to be important because we're going to obtain a critical t value. That's going to be important to make an assessment of whether or not to reject or retain our null hypothesis. All right, and then we have these other equations here, getting the t statistic, and we also have this right here. So we're going to be getting this estimated standard error, but in this case, what we're going to be doing is using the pooled variance. And the reason why we're going to be using the pooled variance is it's a better estimate. So rather than using estimated standard error for two samples, we calculate using the pooled variance, and it corrects for any potential biases that we may have. And so you could write it as this way or as this way. We're getting basically the same information. Well, actually, we're going to be looking at this right here, not this. And this is the information that we're going to gather from here. And essentially, we're using the modified version of this. So this is the version that we're going to be using right here in order to make our calculations. There's other ways in which you can do it, but this is the version that we're going to use in order to get our pooled standard deviation. And we're going to put this pooled standard deviation right here. That's where it's going to go. And then it's going to be square rooted. So at any rate, what I am going to do is direct you through this process of getting this information. So the very first thing that we need to do is, if I'm just going to move this to the side here. So let's see, we have your assignment right here.